Hello everyone, welcome back to the channel. This is the video 5 of Kotlin series. In this video you'll learn about interfaces, abstract classes and sealed classes. So let's jump onto the code right away. Let's go to the IDE, IntelliJ IDE, and here I have a class name, a file oops2.kt and which has a main function. So it just has a println statement. So let's begin with the abstract classes. So you can create an abstract class by using the keyword abstract like this. So let's take an example and take it step by step so that you can understand exactly why do we need the abstract class. So let's create a class named as, let's call it class animal. All right. So now here I have a class animal which has, let's say, a method function get height, and I have another function in here which has function get weight, and it doesn't have any body. It's an empty class with empty methods. So let's create another class named as dog, which is a type of animal. So now I need to extend this class. So for that I'm getting a kind of an exception over here, an error over here, which says that this type is final. So by default, all classes are final and public in nature. So which means that I cannot extend this class animal until unless I use the keyword open. So open keyword will help you to make the class non-final, by which you can extend the class. So here I can see I get another warning here from the Kotlin compiler. It says this type has a constructor and must be initialized here. So I can go ahead and create a constructor here. That's it for this warning. So now let's go ahead and override this method, and I cannot override these methods. I can only override equals, hashcode and toString. I cannot override these methods. So in case I have to override that method, I also have to declare them as open, because by default all methods are public and final in nature in Kotlin. So this is not about Java, it's in Kotlin. So if I have to override this variable, this method, I need to declare it as open. So now I can override the get height method, and I can say a println statement height is, let's say, dollar height, and I can declare a variable here in the animal class, which is val height is equals to, let's give it some 180 centimeters. So alright, so I can also access the height property over here. Alright, so let's go ahead and run this for now. We will create an object of class dog and call the method get height on that. Alright, so let's see what happens. Alright, let's run this program, and we can see the height is 100. So this property is available in my dog class as well. So let's print a statement here that this is the animal class get height method. So we're coming to abstract class. Just be a little patient and understand what exactly is going on. So this is the method I cannot override, and this is a method I can override because it is declared as open. Alright, so let's try to create another method here which says, which is an abstract method. So I will use the abstract keyword and the fun keyword to declare a method and say get name. Alright, so now you can see that I'm getting a bit of an error here. The abstract function is in a non-abstract class animal. So this is the first thumb rule, that the class should be abstract. So a non-abstract class cannot have any abstract methods. So I will make this class as abstract, which means that this and only an abstract class can have an abstract method. Alright, so that's one of the rules. Remember it always. Okay, so now let's try to see what's going on. So here I'm getting a bit of an warning here, or maybe an error. It says class dog is not abstract and does not implement abstract base class member, which is get name method. So there is a liability that we have to implement, or we can say override this method in the subclass. So as you can see, out of here we had a choice to implement this method or not, and here also if I don't override this method, it's not a problem. So everything is fine. I just only have the liability to implement or override the abstract method. So let's click Alt Enter here, implement the members, and select the getName method and say okay. All right. So now everything is fine. So I don't have any liability to implement this or override this method in the doc class, but all the abstract methods should be overridden in the subclass. Okay, so let's write this over here. All the abstract methods must be overridden in the subclass, and only, so this is the first point, only an abstract class can contain an abstract method. So this is the second point. So this goes for abstract classes, abstract class rules, you can say. All right, so this method has to be overridden, and I can just write a println statement here. The height is, sorry, the name of the dog. All right, so we can, let's go ahead and remove this comment. Let's keep that method for now. All right, so let's call this method get name from the main class. So create an object of dog and call get name here. Okay, let's run this program. So you can see the name of the dog is printed, and that's the way you create abstract methods in your class. So the thumb rule is, to have an abstract method, you should have the class name, the class also should be abstract. And okay, let's create an abstract property here, abstract val name equals to, let's say we say it as animal, but we can't do like that because property with initializer cannot be abstract. So we cannot initialize an abstract property. So what we have to do here is that this property must have either a type annotation, be initialized, or be delegated. So what we will do here, we'll just give it a type of string and let it be like that. And in here we can see again there's an error from the Kotlin compiler. It says the class dog is not abstract and does not implement abstract base class member. So the member is the property name. So let's do that. Either we can hit Alt Enter and implement the members, or we can also implement as constructor parameters. So let's go ahead with this, and we are overriding the name here, and now we can print the name of the dog is name. All right, okay, like this. So this is it for the abstract class, and when we create the dog object here, we can pass in the name of the dog. Let's call it husky, and let's call this husky as well. I'm running out of names for dogs, so it's okay. All right, let's run this program, and you can see the name of the dog is husky. All right, so that's it for the abstract classes, and let's jump over to interfaces. So the first rule to remember for an interface is that interfaces are not a class. Like abstract class is a class. Like a class can be declared as an abstract or a normal class. But interfaces are something different, and they are not classes. They're something kind of a listener. Interfaces are kind of listeners, where you can say when you click some button this should happen, or some kind of listener which should get triggered when something happens. So first of all, let's create an interface. So interface is created by using the interface keyword, and let's give it a name here as on click listener. All right, so this is our interface, and we can go ahead and create a button class, button, which will extend this interface, on click listen interface, using the colon symbol. All right, so now this class button is tied up with this interface. So whichever methods I will be declaring in the interface will have to be implemented by this class button. So let's create a method here on click, on click. All right, so now this class has to implement those methods. So I can override that method function on click, and let's create a println statement here. The button was clicked. Okay, so let's give this button a name by declaring a property here. Well, all right, let's do it here. Let's give the button a name is equals to my button, or would be better is if you can just have a parameter in the constructor itself, in the default constructor of the class, well, name as a string property. And let's forget this for now, and you can just say which button was clicked. All right, the name of the button will be printed here. So let's create another method. Let's call another method button and pass it a name. Let's call it the login button. Okay, login button dot on click. So we performed a click on the login button, and then see what happens by running this program. So it will say the login button was clicked. And here we can go ahead and create another button, let's say the sign up button. Let's run this program. The sign up button was clicked. So now I can provide more functionalities to this on click listener by adding more methods here, which will have to be implemented by the button class. All right. So one more thing which is very important to keep in mind is that all the Kotlin classes are by default public and final, which I think I mentioned it earlier as well, but it's good to remember always. And an interface can actually contain an abstract property, it can contain an abstract method. So let's create another function on touch and make it an abstract method. Okay, so now we have to implement or basically override that onTouch method, and we can go ahead and make a println statement here. The name of the button was touched. All right, so this is it, and we can go ahead and call the on touch and click call the on touch method as well for the sign up button and run this program and see the sign up button was touched. Let's provide this on click some body here by printing a statement that I am actually in the on click listener interface dot click. All right, so the on click was, this is the body of the method. Oops, sorry. Yeah, so this is the body of the method. So in an interface you can have an abstract method and a non-abstract method, both of them, so that's not a problem. All right, so we can also go ahead and click here and type in here super dot on click, which will mean that a call to this method will also happen. So let's run this program now and see what happens. So here you can see on click listener dot on click, and then the sign up button was clicked. So and the on click listener dot click and the login button was clicked. So whenever you call the on click method here, all right. So whenever you call the on click method, we are first calling super.onClick, which will in fact call the onClick method over here, the interface method, and then it will perform the actions in the body. If we were to remove the super call, we can do that as well. It is totally up to our choice and our needs. So here we are not calling this super method. Okay, so I think this is it for interfaces. So let's talk about sealed classes for now. What are sealed classes? And I bet you it's a very important feature of Kotlin, and it's really powerful and used in the modern Android app development very actively. So this is a very important aspect of this video. So I want full attention here right now, and if you're not understanding anything, just rewind back a little bit and try to understand exactly what I'm trying to put in over here. So, all right, so let's see what are sealed classes. They are basically an extension to the enums. So enums are basically declared like this. You can use the enum keyword to declare an enum class. Let's create an enum class named as result, and it can have two states basically. Let's say a success state or an error state, and I can basically create an enum like this, enum class, and name it as color, and provide different list of colors like red, blue, and green. So now when I try to access color, here color, I can only have three possible choices. So I'm restricted to a data set of three values. So I can select either color blue or red or green. And same is the case with result. So now I can only have a result which is a success or an error. That is it. All right. So this is one of the functionality which is used to let's say I'm fetching some data from the network. So now the data will have a state, whether it is downloaded successfully, it got a success, or it got an error, whether data was interrupted while downloading or some kind of exception happened and the data could not be downloaded. So for that two states, I have created this enum class. But the issue with this is that even if I have to provide so add some functionalities to it, let's say I need to also send the exception, what kind of exception happened when I tried to uh, pass on the state. I cannot do that using an enum class. But some of you might say that we can do it using an abstract class. If I just declare this class as abstract, and then I can go ahead and add parameters to these classes. But I can make these as classes like this, and I can add some parameters to this as a constructor. But the issue with that is that with this class result now over here, result, I'm not restricted to two classes. I can have more than that as well. So I'm not basically restricting myself to two or three. So this will not suffice for, with so let's give it back, remove it, and move this. Okay, so now this is the reason why Kotlin created sealed classes for us, and let's see what exact functionality do we get from the sealed classes. So I'm just going to go ahead and comment this and use this as a sealed class. So before that, let's try to understand what is the actual need of a sealed class. Here I'm trying to use a real world Android app example, which is used by many Android developers right now. So this is coming straight out of a production level code. So I want you to focus, full focus here, and try to understand what I'm trying to say. So let's create a class named as result, and it has two classes. Let's say class success, and it is extending the class result, and I have another class called this error, which is also extending the error class. So now the result class. So now the thumb rule is that, which you must have known from the starting of this video. In order to extend a class, we need to define it as open, because by default all the classes are public and final in nature. So here I need to also declare a variable as in the constructor. I need to give a parameter. So I will name it as data of string type, and here we can have some kind of error of string type or whichever type you are comfortable with. We can keep it as val or var, with whatever you're comfortable. Alright, so this is our class result. So now let's create a method get data from internet. It will return me some kind of result. Let's assume that this is the code which fetches up data over the internet. This is the body of that code, and it gives me a result code. Result code equals to 200. Let's say these are the result codes. 200 stands for success and 406 stands for error, or anything else stands for. So this is basically just a simple if else condition. If the result code is 200, then we have success, otherwise we have the result as error. Let's call this method, let's create a variable here, result equals to an expression, and call get data from internet, it will give us two values. Either it will give us result dot success, I have to say is result success. In that case, I can println result is success. Either it will be an error, result dot error, and we can say println the result is an error. Okay, so now this is good enough. I'll add a else statement for now. Let's try to run this program and see what happens. So we can see the result is success because of the code. Let's change this code to 201 and see what happens. Now we get the result is an error. So now in future we get another requirement that the result code is specifically 201. We have to show that the result is in progress state. So now these are the different states: success, network error, and in progress. Alright, so what I will do is I will add another state here, data class, another state which is in progress state. I'll say some progress value which is an integer number. I can pass some integer number, and if the result code is equals to 201, then write result dot in progress, and we can pass in some random value here. The progress is how much is the progress. Let's say it is 20 for now, which we will get, assuming that we will get from the while we are fetching the network from the data. So let's run this program. We have mentioned the result code as 201, and we should get the result is in progress. But hey, what do we see? We say that the result is unknown. So this is exactly the problem that we are facing right now, and we want to overcome it. So we didn't get any kind of error here which says that okay, you have to add result error result dot in progress here. What we can do is remove this open keyword here and make this class a sealed class. So now what will happen is that when I'm returning an in progress here, this when expression is giving me a bit of a hint that expression should be exhaustive. Add the necessary in progress branch. Add the remaining branches. So now I can go ahead and say result is in progress. So let's run this program. Now I'll get that the result is in progress. So now in future, if any of the things changes, like I add another data class into my result here, network error. Alright. So if the result code is specifically 400, we call it as a network error. I will come here, add another else if the result code is equals to 400 specifically, then I will return result dot a network error, and I can pass in some error here. Let's call it error, and it can be string sub data with exception value of network. Okay, so now we see a bit of a red line here. Let's see what this is. So we get a compilation error here. It says when expression must be exhaustive, add the necessary is network error. So did you see that after adding the class, after making the class a sealed class, if we update the sealed class, we get the Kotlin compiler automatically tells us, it gives us a feedback that you are missing something here. So this is the one of the major advantages. I can go ahead and add the remaining branches, and now when I make this value as 400, I will get the response as a network error when I run this program. I know guys, it is a lot to take in for now, but I believe this is a very important feature of Kotlin sealed classes, and you must definitely know how it works. So I've tried my best here to make you understand what is the real world scenario here and why do we need a sealed class. Okay, so if you have any doubts with this sealed classes or interfaces or abstract classes or in Kotlin in general, please feel free to comment on below and I'll be happy to resolve your comments. So I'll see you in the next video, probably a next new course. So until then, pay must and keep rocking.